Okay, hi. Thanks for coming to my talk. My name is Einar. Before we get started, apparently at 12 o'clock, there's going to be like this emergency test for notification through all your cell phones, which means that your cell phones are going to scream like developers who see someone else's code. So if you want to avoid that, and maybe you should to avoid sort of like embarrassment and heart attacks are very embarrassing, maybe put your cell phones in airplane mode or turn them completely off. I think there's also going to be like these terrible foghorns, so maybe there will be a slight break for like 3 minutes or something in the middle of the talk. Okay, this is a talk about a meeting of two zombies called Agile and Architecture, both undeniably dead and yet still both undeniably walking among us. For architecture, it's very easy because we have the exact time of death, which is February 2001, because it was murdered by Agile, right? In this attempt to sort of overthrow the arch enemy called Waterfall. They also killed architecture. For Agile, it's been more of a gradual thing, right? So it's been in declining health for a while, and I think we can declare it dead now. But that's good, because now that they're both dead, they're sort of like at equal footing. So we can have like a blameless retrospective and talk sort of candidly about what we tried to do and what went wrong and what's going on in the land of the living. A few words about me. My name is Einar Høst. I'm a Norwegian software developer. I have been making software for money for 20 plus years. I've been around for roughly as long as the Agile Software Manifesto, which means I guess I've outlived both architecture and Agile. I've survived both UML and Scrum, so okay. I currently work for NAV, which, if you're a Norwegian, you know what NAV is. It's the Norwegian Labor and Welfare Administration. We're a fairly large organization, and we administer a lot of money that we use to provide services such as unemployment benefits, sickness benefits, child benefits, pensions, and so on and so forth. And yeah, so this is talking about Agile and architecture. And when you talk about Agile and architecture, typically you get this idea or this impression that there's some sort of tension there, like Agile and architecture are somehow at odds, and that architects and Agile practitioners don't always see eye to eye. So typically, in discussions about Agile and architecture, often people will talk about we have to strike a balance, right? And again, this plays into this idea that Agile and architecture are somehow opposites on a scale. So you get into discussions like this, right? How much architecture should we have? Which sounds a bit odd to me. Like, you mean like in kilograms or volume? What's the unit of measure for architecture? But I guess sort of the underlying idea here is that too much architecture stifles agility, right? So it comes at the cost of agility. And similarly, you have the opposite question: how much agility should we aim for? And I think that often translates into how much autonomy should teams be afforded. And the idea here, I think, is something like too much autonomy makes sort of the architecture fall apart. And so the solution is kind of obvious. So we need just enough of both, right? We don't want too little, we don't want too much. But at the same time, while this is arguably true about anything, right? So it's sort of like a tautology, it doesn't tell me much. So it's not something I can use as a heuristic, because I always want to have just enough. But unless I can tell what just enough is, it's not going to help me. But I think our brains are sort of wired to look for these balances. So it's very comfortable if we can take two things and place them on opposite sides of a scale, and then we can sort of like reject the extremes, right? And do something in the middle. And that seems right? But if that approach is going to work, then they have to be opposites on a scale, and it's not obvious to me that that's actually the case for Agile and architecture. So for that reason, I'm not going to do a talk about balancing Agile and architecture. I wanted to start somewhere else and do a different kind of talk. So I want to start with why. So why are we talking about these things in the first place? Why do we have these two zombies sort of roaming around? So why are we talking about architecture? Why do we have such a thing as architecture? What are we trying to accomplish? What is the problem we are trying to solve with this thing called architecture? And similarly for Agile, why do we have the idea of agility? Why is that a term for us? And what are we trying to accomplish? In fact, this sort of applies to anything, right? Why would we do anything at all? Well, you do things because you have the idea that it's sort of providing some sort of value. And if you discover that it's not bringing a lot of value, maybe you do less of it, and you maybe try something else instead. So this is kind of obvious, but just because we've been doing Agile and architecture for a long while, unless it's providing value, maybe we should do something else. Well, okay, so we need to ask questions like these, I think. Like, if architecture is the answer, what is the problem? Or what is the question? Right? And similarly for Agile. And I think, for me at least, it's interesting to ask this question. Is it the same problem that we're sort of addressing with these two different approaches? And one answer to what problem we could conceivably be trying to solve using Agile and architecture is this thing called the software crisis, which is sort of a notion that was first, I think, articulated in 1968 at this NATO conference for software engineering and blah, blah, blah. And it's been with us ever since, right? And the software crisis is that software projects tend to run over budget, over time, low quality, doesn't meet requirements, sometimes isn't delivered at all, and so on and so forth. And this is a bad state of affairs, right? So this is a crisis. And this is a quote by Edgar Dijkstra, the famous Dutch computer scientist. He says, I'm going to read this out loud. He said, the major cause of the software crisis is that the machines have become several orders of magnitude more powerful. To put it quite bluntly, as long as there were no machines, programming was no problem at all. And when we had a few weak computers, programming became a mild problem. And now that we have these gigantic computers, programming has become an equally gigantic problem. This is 1972. Right? And computers have become more powerful and also much more ubiquitous. So there are computers everywhere, right? And for that reason, I think we've had this crisis for like 50 years. I think we can trust the crisis to sort of stay with us, right? In a field that constantly changes, at least this is a stable state of affairs. In fact, our ambitions for what we want software to accomplish is going to continue to rise. There are going to be even more. There are already computers everywhere. There are going to be even more of them. We want them to be more and more sophisticated. And there's this sort of economic pressure as well to do more with less. So, how do we tackle this crisis then? And in the 70s, people like Dijkstra and David Parnas were discussing things like structure. If we could sort of focus on the structure of the software, maybe that's going to help us. So we have ideas like modular design. How do we partition our software? Can we do that in a way that makes it easier to build better software systems? So with high hopes for stuff like components. And the idea is also, if we build really good components, maybe we can reuse them. And we don't have to start from scratch every time, because we're not doing a terribly good job at writing software. So maybe we could do it fewer times and sort of exploit the result after it's been debugged and so on and so forth. So you can bypass some of these problems with the bugs and the late deliveries if you can reuse something that's already made. So in 1992, two people named Perry and Wolf predicted that the 1990s was going to be the decade of software architecture. And the software architect would be sort of the person who would lead this process, if you like, right? And I think Perry and Wolf were right in that the 1990s was the decade of software architecture, perhaps even more so than they sort of intended with that statement. But okay, 1990s, we saw the rise of the software architect. And what was the software architect supposed to do? There was this joke about architecture, is that what is architecture is what the architects do. And what does an architect do? Well, it tends to the architecture, right? there are a gazillion definitions of architecture, and the sort of new definitions come all the time. That doesn't necessarily speak ill of architecture, I think, but it doesn't necessarily speak well of it either. But this is a definition of architecture. And I'm going to read that as well. The architecture of a software system is its organization or structure of significant components, since this word components, interacting through interfaces, and those components being composed of successively smaller components and interfaces. So there's this sort of recursive thing where you can sort of compose things into larger structures. This definition is from a rational unified process, which is, I think, sort of like the mid-90s. Right? This is how people were thinking about architecture in the decade of the software architect. So we had a unified process. We also had a unified modeling language that you could use to express architectures. There was something called the 4+1 view model that was supposed to sort of illustrate different aspects of your software system. And then, of course, there was the patterns movement, which was kind of interesting. It took inspiration from a real, sort of the real building of, or from architects of real buildings, like Christopher Alexander. And maybe some of you have read some of his books, like The Notes of the Synthesis of Form, which is a really excellent book. And there was much hope, I think, in sort of capturing known solutions, not just building these components, but also more like abstract patterns. How do we sort of make these things fit together and use that to compose better architectures? Okay. The most prevalent architectural pattern was identified in 1997, and it's called the big ball of mud. Now, unfortunately, everyone has heard of the big ball of mud, but very few people that I meet have actually read the description of the pattern, which was sort of articulated by Foot and Yoder. Well, you can see the link here where you can read it, and I think that's a shame, right? But it's also sort of unavoidable in a pop culture like software development is. Right? So the sound bite sort of survives. We know, oh, it's a big ball of mud, whereas the analysis that sort of underlies that sort of dies. So when I do this talk, I try to place a curse on the audience, which is that you will no longer be able to articulate the words big ball of mud until you've actually read this. Now let's see if I have like magical powers. Okay. Since the earliest definitions of architecture, we've seen some scope creep, and that goes along with this sort of changing definitions of architecture. So from talking about these structures and components and interfaces, we talked more about like desirable system properties like testability, security, scalability, resilience, and so on and so forth. So in a sense, it's become more abstract and more tailored to what are the things that we're trying to accomplish, more than the exact means of how we're going to do that. So here's another definition. It says architecture represents the significant design decisions that shape the form and function of a system, where significant is measured by the cost of change. This is by Grady Booch, and I'm not sure exactly when this was first articulated. I think Grady Booch still promotes something along these lines. But okay, so the decade of the software architect was over. How did all of this go? Well, it didn't turn out so well, right? 2001, Agile comes along, and architecture is killed by the assassin known as Agile. But why? So why would Agile kill architecture? And I think it's important to talk about. This is going to be a little bit uncomfortable if you're an architect, I guess. And it's uncomfortable to talk about, but at the same time, when things are uncomfortable to talk about, that's when we should be talking about them, right? Because that's where you can hope to find some value. And I think the problem with architecture as it was practiced in the 1990s at least was irrelevance and harm. And I'm not going to argue that, well, there was no good architecture work in the 1990s. Sure, I'm convinced there was. But at the same time, many people experienced architecture, and in particular, perhaps architects, as useless in the best case, right? And then harmful, actively harmful in the worst case. And I met many developers who express a view that they've never experienced working with the software architect that did more good than harm, right? And that's pretty harsh, and it's very tempting to sort of try to shoot the messenger and say that that's not a valid experience to have, but that's not the way to learn anything. We need to understand where that sentiment comes from if we're going to do better. But why? How could this happen? Right? So this is a terrible state of affairs, if that's true. Because architecture, after all, sounds good. It's trying to sort of imbue our systems with these desirable properties, right? It tries to do good things. One thing we might ask is why did we sort of come up with an architect to deal with the architecture? And one reason that we might have is that it's a good idea to sort of have one architect to ensure the conceptual integrity of the system that we're trying to build, right? So you sort of want it to be the brainchild of a single person with a single vision for what the system should be like. And it also matches sort of this idea of a master builder, right? With one very knowledgeable architect, and then you have like these minions carrying out the sort of menial task of implementation. This sort of ties into something entirely different, which has to do with economy, because knowledge is expensive, right? So if you can have one expensive person and then some cheap or inexpensive people sort of magnifying the impact of the expensive person, that makes economic sense, right? So skill costs money, and so you have a highly skilled person and then a bunch of code monkeys to sort of do their bidding, right? So I think, unfortunately, in many cases, the idea of architecture was implemented as sort of an anti-pattern, right? So in this case, this diagram, we have 8 teams of developers being served by a single architect in the middle, which is the yellow dot. Or perhaps, if you're sort of a big organization, you have a board of architects, which is the yellow dot, right? And there are a bunch of problems with this arrangement. First, it sets up the architect to be sort of a bottleneck, right? So you have asynchronous communication, so the team sort of sends a message to the architecture board and then they hope for a response. It's slow, and it's sort of detached from reality because sort of the architect can never have the degree of knowledge that the teams have with what's going on inside the team and their reality, right? So they cannot have the full context in mind, and which in turn leads to poor decisions and a loss of trust between the developers and the architect. There is potential conflict of interest as well. So if you're a team of software developers and you need to make an architectural decision, what are you looking for, right? And from the team's perspective, the most important thing is that it's sort of fit for purpose, right? It solves their problem. You want something that's as simple as possible to solve the problem in your context. You want to solve a particular problem in a particular context, not everything else. That's not important to you because as long as it solves your problem, you're good. And it just needs to take into account sort of these local concerns. But then again, it's vitally important that it actually takes those into account. Otherwise, it's sort of useless, right? And it needs to be what you call sort of internally legible, which means it's sort of understandable from within. That's the most important thing, right? It needs to make sense for the team. There's an emergency. It's not terribly disruptive. Should I just keep going, right? Yeah, I think I'll just keep going. If you're an architect, you might have other concerns that are not the team's concerns. And in fact, you might the organization might make up their opinion of whether or not you're doing a good job by looking at entirely different things, right? So you might have other priorities, other goals. So for an architect, uniformity might be a goal, right? It's a good thing if things are uniform, right? In general, a general solution will be better than a specific one, because then you don't have a gazillion different solutions all around. So you want the general solution. And then because you're looking at the system from the outside when you're an architect, you want it to be sort of understandable also from the outside. Right? That's the most important thing, that it's externally legible. Right? You understand the architecture when you're looking at it from a distance. Now, it's important to note that these are all systemic problems. Right? It's not that the architects were stupid and they were doing a bad job, but in many cases, architects have been put in a bad arrangement, and it led to bad results. And then Agile happened, and I said that it was an assassin, but perhaps it was more like this, like it was a revolution, right? So February 2001, we got this. This is the Manifesto for Agile Software Development. And I'm sure you're all familiar with it. It says individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. And then they say, while there's value in the things to the right, we value the things on the left more. But of course, the first thing that happens is that sort of nuance gets lost, right? So all these things on the right get sort of stricken out. And if you're an architect, that spells bad news, because I think in general, an architect is interested in these things on the right? So that's basically their job, and that's why they were killed. But okay, we have this revolution. When the smoke settled, what did we have? Out of the smoke emerged Scrum and Jira, which is, you know, a process and a tool. I mean, it's literally the first sentence of the manifesto, individuals and interactions over processes and tools. But at the same time, you can understand this because it's much easier to roll out something like a process and a tool than to roll out individuals and interactions, right? So it's easier to implement. But I want to talk a little bit more about Scrum. So I'm a Scrum survivor, yeah. But Scrum is very important to the story of Agile, right? Scrum very early on sort of emerged as the winner of a competition of sort of these lightweight approaches to replace whatever heavyweight things they were doing in the 90s. Right? And I wasn't aware of this until fairly recently, but apparently this is by Alistair Cockburn, which is one of these sort of original Agile gangsters, if you like, one of the signers of the Agile Manifesto. Also the inventor of hexagonal architecture reports and adapters, and a lot of other stuff. So a very interesting guy. But okay, so what he was saying was that apparently Scrum very deliberately set out to make a deal in a hostile environment. Right? He said, Scrum struck a magnificent bargain in hostile territory. Management got 12 times a year, 1 time per month, to sort of change direction in any way they wanted. This is your sort of your sprint, right? And then the team got 1 month of total quiet time with no interruptions or changes to direction to do all the heavy thinking and working. So this, what really happened was sort of like this, right? So you have Scrum invented to function in hostile environments, and it creates this interesting contract between the sort of like hard-pushing executives on the one hand, and then the software development people needing time to think, and to work without interruptions. So the idea in Scrum is to create this sort of protective terrarium for software development, right? Where you shelter the team from the environment, because the environment is kind of noisy and there's politics and stakeholders and noise. So you try to control and optimize the conditions inside the terrarium to avoid too much and too little of everything, right? Because if you have sort of too much stress, it's going to make the team lose their motivation. And if you have too little, well, they're going to grow lazy, right? And all the while, you're sort of asking the busy silkworms if they're thriving, if they're feeling psychologically safe, and still having this mild pressure to maybe produce a little bit more next month, right? Because we really need that code, and have you set your stretch goals, right? So, because we really need that silk you're producing, right? So we have sort of two sides. On the one hand, you have the software development team, which will produce feature in exchange for protection against sort of the noisy outer world. And then you have sort of management on the other side. They're willing to offer protection in exchange for features. Well, you'll notice there's this asterisk up there, and that's because it's management and they're sort of used to writing contracts, right? So you have to, some conditions apply, right? So you have to follow certain practices, for instance, and some rituals as well. For instance, those dictated by Scrum. And there's this other guy called Brian Marrick. He's another one of the sort of original Agile gangsters. He has this podcast called Oddly Influenced that I really recommend. It's very interesting. And in one of the episodes, he discusses this kind of gift exchange between management and software development teams. And there is one thing that's very interesting, I think, in the dynamic between teams and management here, because the cost of offering protection is fairly stable, whereas to produce ever more features, there is this caveat that the new features need to fit in with how you implemented the previous features. So it's getting increasingly hard because you're stacking up all these features. But whereas the only thing that can really threaten management's ability to offer protection is that everyone is getting angry at the development team because their velocity is going down. But okay, that was 20 years ago. What has happened since? Has nothing happened? Well, not quite. In fact, quite a lot has happened. We've seen scope creep for Agile as well. So it started out with the Manifesto for Agile Software Development, which is really about what the development team should be doing. And that's sort of over time turned into a focus towards something like Agile product development, which has a broader scope, right? It's more about, it's not just the software that we're writing. And perhaps we even want to have like Agile organizations because we want to do Agile business, whatever that is. But there's something we want to be nimble, right? And we acknowledge that change is important in other places than just in the code, I guess. Now, we've had this sort of like endless stream of self-help books coming out of Silicon Valley to help us in this journey, right? Where the winners of Silicon Valley have written up their recipes to be followed, sort of like confirmation bias be damned, right? Because they were successful, and if you do whatever they did, maybe you'll be successful too. And it's not sort of a logically valid conclusion, but you'd see why people would hope that. So they're all selling these various kinds of what I like to call radical pixie dust to sort of sprinkle on top of your Agile transformation. Who here has read A Radical Focus? A few people. Radical collaboration. Radical candor. Radical empathy. Now, at some point, it gets hard to know if I'm referring real books or just making shit up. I think these were all real. But okay, so the idea is if we follow these sort of practices and approaches, maybe it's going to help us achieve this Agile dream, right? Now, interesting question is, has it worked? And I think we've tried, right? We've put in a lot of effort trying to do these things. And in general, it's kind of hard to talk about because when you talk about practices like this, everything's a success until it's sort of silently abandoned. Right? So if you talk to teams today that are implementing OKRs, objectives and key results, and a lot of people are, we're doing that at NAV, and we're hoping it's going to provide value for us. But if you're asking them today how it's going, you're bound to get an enthusiastic response, right? It's really working out really well for us. If you ask them in 3 to 4 years, they're still doing OKRs, we'll see, right? And this is what sort of time does to you. That you get a little bit cynical because you've seen some of these things come and go before. But let's hope, right? Because we're investing in this thing. But over time, what I've seen is that very little seems to stick, right? And for that reason, things have gotten a bit weird. Right? So the ideals for teams, our ambitions for what we want to do with Agile have evolved. So we're talking about like bridging the gap between business and IT. We should be as customer-obsessed as Amazon used to be, back in the day when Amazon was customer-obsessed. We want to grab a seat at the table, right? So the developers should be involved in strategy decisions and so on and so forth, not just care about the code. Whereas, it seems to me, reality is largely the same. And what is the reality? Still largely the Scrum Pact, right? Teams being sheltered from the environment. So we have this development terrarium, which might look something like this. And a main problem with the terrarium is also its strength, right? Which is the isolation from the rest of the business. It's very hard to communicate effectively with the rest of the business if you're sort of setting out to not communicate with anyone during a whole month, and then you're sort of intensely communicating, and then you move on, right? And also, sort of communication happens through these mediums that sometimes we call team leads that can cross between the world of the terrarium, where the developers live, or the software development team live, and the world of the business. And again, here you have the problem that communication is asynchronous, slow, lossy, and so on and so forth, which leads to bad decisions. And we've heard this thing before, right? It's the same problem we had with the architect. And I think there are some uncomfortable truths here as well. And I think one of them is that while developers have sort of learned the ideals of Agile by heart and can say the right things at the right moments, in practice, we're kind of happy with the protective terrarium, right? Because life as a silkworm is quite comfortable, right? So your job inside the terrarium is to consume these sort of well-defined Jira tickets, right? So you have silkworms. I think they feed on mulberry leaves. Developers feed on Jira tickets. And also, it's sort of a safeguard, because if we stray too far from the Agile ideals, it's because management didn't allow us to do the things that we wanted to do, right? So anything goes wrong, it's due to things happening outside the terrarium. And that's actually often true, but maybe we should change the state of affairs then, right? And I think there's also something like command and control never really died, right? So you can have autonomy inside your box. Okay. So I like to quote Henrik Ibsen, our famous Norwegian playwright, who said, "Don't use that foreign word ideals when we have the excellent native word lies." And I think we have some lies, and we're quite comfortable with those lies, right? Because they allow us to have the best of the both worlds, right? So we can talk in the world of ideals and live this other life. But okay, so architecture is dead. Agile is in bad health, and whatever it is not really agile. What are we supposed to do? We still have this crisis to handle, and maybe we should return again to the problem. Right? So what is the problem that we're trying to solve? And in a sense, to me, the biggest unsolved problem in software development is the passing of time. Right? And the problem with time is that it brings change, and with time would just stop. Right? We would stand still, then we could sort of catch up and have a good, healthy software architecture, right? And we wouldn't have all these problems. But of course, time isn't likely to stop, so change is likely to continue to happen. So the problem with time is that things happen, and some of those things affect the systems that we're trying to make. And then you're in the situation where your system now must change to reflect a new reality, because the change sort of new reality, because the change sort of changed something and it's relevant to you, and now your system should change as well. The problem is of course that more is dead than Agile and Architecture, and it's up to us to make the code appear to be alive. There's a movie called Night on Earth. This is one of my favorite movies. And this movie confesses a lot of sins to his passenger, who is a priest. And the priest has a heart attack and dies in his taxi. And the taxi driver realizes that this is bad, right? This could be very bad for me. So he tries to sort of sit him at a bench and make him look alive for a while, so that we won't be discovered immediately. And this is how I picture developers and code, right? So you have the programmer desperately trying to make the code look alive, right? So this is really the software system, right? So there's this sort of union of the program and the code. So software, in a very real sense, software systems are cyborg systems, right? And we notice this instinctively also because if a maintainer of a library that you're depending upon sort of stops working on it, then it's like panic, right? Because the library is dead, right? It cannot respond to change anymore, and you start looking for alternatives. So you want sort of these live things. Just the code is not sufficient. You need sort of the combination that is sort of alive. And it's because changes must be responded to by people. So how do we do that? How do we respond to change? Okay, so responding to change, first we need to detect that some change has happened. And then we need to evaluate the impact on our system. Is this relevant to us or not? Of course, the great majority of changes in the world will not hit our system. And that's a good thing, because otherwise we'd be really in trouble. But still, things affect our system. So we need to identify then the gap between the sort of system as it should be and the system as it happens to be today. Find out if and how to respond. So should we do something about this? And then you have some trade-offs, and you need to make a decision, and finally, you actually need to close the gap. Right? If that's something you need to do, you should close it. And then, presumably, you're done, right? And so, but still, all this happens under a set of constraints. So first, time again. So we don't have infinite time to respond to any particular kind of change. We also don't have like infinite money, which sort of amounts to the same thing, right? So any kind of change, we're going to have to sort of time box, right, our response to it. So you need to get it done. Knowledge and skill is going to be a factor as well, right? How we figure out whether or not we sort of can come up with a good change to implement our system. And then there's inertia, right? Because all the code we've written, it has sort of mass, right? So we might need to sort of struggle with that mass and sort of work with it. And that's going to offer resistance, right, to the change that you're trying to make to your system. And for that reason, imperfections can sneak in. And over time, they typically do. You have shortcomings, remaining work. And we often call that debt, right? And we have many kinds of it. Typically, we talk about code debt or technical debt. There's also like modeling debt. We didn't really take the time to reflect on how this affected our sort of domain model, if we have one. We can have architecture debt, right? Our architecture is no longer ideal, but we're sort of making do. Organizational debt, because architecture is typically socio-technical, so maybe you should actually sort of move your teams around a bit to reflect this change. Knowledge debt, right? So maybe you haven't really taken the time to let it sink in and build the kind of knowledge you need to handle this change properly. And maybe you didn't communicate with some people that you should have talked to, and maybe you didn't really make a proper decision, right? So you just let it slide. Now, over time, you're going to get something called reified assumptions, which is a bad thing. So assumptions are assumptions. Reified means that they're sort of made concrete and has entered the structure of your system, right? So you built them into your system now, which makes them hard to take out. Which over time leads to lost degrees of freedom, which makes your system less flexible in the face of future changes. So this sort of code corpse that you're dragging around is getting stiffer, right? And it's harder to make it appear to be alive. So we tend to call it technical debt. I think that's sort of pointing in the wrong direction, because it's really a natural byproduct of the combination of change and inertia. So this is always going to happen. It's always going to build up. Okay, so let's talk a little bit about change then, because we like to say, like, and this is like a clever thing to say, right? So change is constant. It's the only constant in the software development world. And that's kind of true, right? So the time is going to keep ticking, so change is going to keep hitting our system. But I think it's worth reflecting on where do these changes come from? These changes that affect our system, where do they come from? What kinds of changes tend to hit our systems the most? How often are we hit by changes? what are the sources of change, and sort of what is our system's exposure to change even, right? What is the change surface of our system? And is there something we can do to affect the number of changes that hits our system? I think we can talk about, we like to talk about necessary and accidental complexity. I think we can also talk about necessary and accidental change that affects our system. This is very important because every team has a limited capacity to handle change. So you want to prioritize the necessary changes and not have all your capacity taken by accidental changes. Okay, so when we talk about changes in software, typically we talk about changes that affect the code in some way. And I think we often talk about, well, there's a change in the business requirements, and now we have to. So they change their minds again, and now we have to, right? So the business or the domain might change, and that does happen. It changes, I think, less frequently than the technology itself, right? Technology changes are rapid. They're sort of like daily, right? Changes to libraries and frameworks and everything. Changes much more quickly and frequently than the domain. This is important because today most applications are these like iceberg applications, right? Where there's a little bit of your code on top, and then there's this set of dependencies, this transient set of dependencies, sort of a murky, long beneath the surface. And the kind of strange situation is we don't often, I don't think we really know what all of those things are. But one thing that we do know is that there's some change out there, like a security hole that's been discovered or something like that, that's going to affect us, right? So it is part of our change surface of our applications, right? So we might have to do something when they change. And it means that every dependency that we have on some other component or whatever is a subscription to a stream of changes. And all of those changes to dependencies are in the category of accidental changes. Right? So those are not the necessary changes that you need, that you should be focusing on. Right? These are accidental artifacts of the fact that you happen to depend on this particular thing. So I think it's worth considering what is the percentage of time that we spend on these sort of necessary or essential changes. Right? And maybe we can do something to reduce our exposure to accidental changes. And this is important because we want to protect our capacity to change and use it for the right things. So, what are things that can affect our capacity for change? Because, again, software is this cyborg, so it's not just the code, it's also the people. So there can be changes that affect the people as well, which affects, in turn, our ability to handle change. An obvious thing is that the team changes in some way, right? A team member leaves, a team member joins, you have a different team. There could be changes in the environment. One of the changes in the environment that can have sort of dramatic effect, and that can also change the team, is that stuff like funding is cut, right? So you can no longer afford to have 4 developers, now you have 3, right? And that is a change that is going to affect your ability to handle change. And basically anything that hits your diversity, the level of trust in the team and between the team and the environment, the motivation of the team members, their knowledge, their autonomy, their intent, is going to sort of affect their ability to handle change either positively or negatively. Right? And this is important to be aware of because we want these sort of healthy, sustainable cyborgs, not sort of cyborgs that give up after a while. Right? And like get into their taxi and drive away. And it's important when we try to come up with solutions, it's important to remember that human vices are constant. This is actually constant, right? People are not going to get more like disciplined or more professional or better in some way, more intelligent or whatever you want to optimize for. People are people. We're not going to improve much. So solutions must be sort of systemic, right? It must be in what we do and not trying to sort of try harder, right? So when you talk about discipline and professionalism, those are just euphemisms for trying harder, and we cannot try harder. We're not going to try harder. So what should we do? I think we could start at the organizational level. I was talking about this terrarium. I think if we believe in this agile dream, we need to sort of break out of this terrarium. We cannot have this isolation. So I think we need self-sustaining teams. In a sense, it would be nice if teams would be more like tiny organizations in their own right. And then your larger organization is this sort of like loosely coupled alliance of tinier organizations, which are the teams. So you need some sort of actual autonomy for the teams. And to do that, you need to move the money inside, because if the money is outside and you say the team is autonomous, you're sort of just kidding yourself, right? So the team needs their own budget to administer their own money, otherwise they're not really autonomous. You need, obviously, non-techies inside. This is an area of the industry where we've seen some improvement, I think, right? We're starting to realize that a cross-functional team is not just having like a developer and a tester, right? We want actual domain experts and sort of whatever you need to build a system, you need that to be part of the team, right? And you need to put like important decisions inside, not just the tech stack, not just will they let us use Haskell this time, or will they let us use Rust or whatever? That's not an important discussion. There's not a sort of like a business owner in the world that really cares about these things. And you need direct communication. Direct communication is both with stakeholders. So maybe you have like an architect or an architecture board, right? They could be sort of like constraint setters. So we need to ensure that the system is like this and this and this. They can own that, and you communicate with them. Right? That's fine. You also need a direct communication with customers or users. So not something that goes through some other person. That is sort of the team's job to communicate with the customers and users. And this is important because without this direct communication, feedback is a bluff, and Agile sort of feeds on feedback. So there is no Agile without like proper feedback. At the team level, seek independence, I guess. Minimize these dependencies, because dependencies are subscriptions to streams of changes. If you can, sort of don't do left pad, right? So don't download left pad. Don't have like unnecessary dependencies, because it's very easy to just sort of download it. Now, if it's simple, if it's not terribly complicated, maybe consider writing it yourself, because you don't have this subscription then. And I'm not saying like write your own crypto. Don't do that, because you'll be in problem. But for simple things, consider doing it yourself. Obviously, protect your internals. If someone sort of goes in and grabs your data, you're sort of it really limits your ability to handle change. Retain and rebuild knowledge. This means working groups. You can like pair programming or mob programming or ensemble programming or full team programming, ideally. That is the only way of sort of knowledge transfer that I know sort of works, right? So you want knowledge transfer to be continuous and by osmosis, by working together. And this really helps onboarding as well, because you just join the team, right? And then you pick it up as you go along. And one thing that you could consider is rewrite a part of the system when you're onboarding a new team member. But you do that as a group also. Right? That's a good way to get into the system. And you want to avoid churn, because whenever a team member leaves, you lose knowledge, which affects your ability to handle change in a negative way. Architecture level, well, first, it needs to be team-oriented. I'm talking about these different perspectives, the perspective of the team and the perspective of the architect. And in a sense, architecture is too important to be left to architects alone, right? So the team needs to own the architecture. Architecture decisions should primarily be sort of take into account local concerns, needs to be fit for purpose, needs to be understandable from the inside. And I think it should be observability driven, right? So we talk about these quality attributes that we want our software systems to have. We don't really have any quality attributes that have not been verified recently in production. We might think we have, but we need this constant revalidation for that to be true. And the good thing about this is that it allows you to broadcast the state of your system as well. If you have an external architect that looks at different kind of systems from the outside, you can give them access to some of your observability statistics or some of your dashboards, and then you can sort of see for themselves that, yes, this is actually the way we wanted it to be. So this helps make it also externally understandable. There's simplicity. We talk about this a lot, right? So we should build simple systems, keep it simple, stupid, and all that. And then in practice, we do something else. So we should minimize the moving parts, and we should avoid sophistication, which here is the tricky thing with complexity. Complexity never introduces itself and says, hi, I'm complexity. It says, hi, I'm sophisticated, right? And we shouldn't fall for that trap. We should avoid sophistication if at all possible, and go brutalist instead, right? So do the simplest thing that could actually work, and don't have sort of these sort of additional layers on top unless it's absolutely necessary for some reason. For instance, like, just use HTTP if you're going to call someone else. Don't use this like SDKs on top of SDKs. It's not necessary. And it's going to be HTTP things anyway, and you need to understand how that works anyway. So maybe just get rid of all the junk on top. And then you also don't have their changes to worry about. Embrace constraint, preserve options. You want it to be organic, and how do you make things organic? Well, one thing that we're starting to get really good at is to put things into production. We're not very good yet at taking things out of production, and it's because we don't think we'll ever have to do that. And in a sense, that's true, because someone else probably has to do that, but that doesn't really solve the problem for the industry, right? So we should have a plan for how could this be decommissioned, right? And this is the thing about reducing our change surface, shrinking the iceberg, avoid dependencies that are not absolutely crucial and that you're not absolutely certain has a healthy trade-off between sort of the value that you're getting and the amount of work you have to do to preserve that dependency. Okay, to summarize, well, first of all, it's not a balance between Agile and architecture. You do as much Agile as you... If Agile delivers value, keep doing it until it doesn't add any more value. If architecture provides some sort of value, keep doing it until it doesn't add any more value. And if it doesn't add any value at all, do something else. Right? So it needs to be aligned with what's providing value for us. Architecture is important. It belongs in teams. We should smash the terrarium, even though it's uncomfortable, and we need to build these sustainable cyborgs. And with that, the talk is done. Thank you.